For the next three problems, we're finding the domain, but now we're doing an interval notation. So this should be some review stuff from earlier in the semester. Remember, we don't want division by 0. On number 7, we could have division by 0 if x was 3 or negative 3. X cannot be 3 or negative 3, but everything else is okay. So the interval notation for this, for the domain, is a little messy, but everything works from negative infinity until I reach negative 3. I put a parenthesis on that because it doesn't work. But then I pick back up right after negative 3, hence a parenthesis on it, and everything works until I get to positive 3. And then everything from 3 to infinity works, but not including. So this is basically the interval notation way of saying don't include negative 3, don't include 3. Somewhat messy notation. For number 8, we've got this even root, the square root, and it's also in the denominator. So remember, we've got really two things to worry about here. Usually I would say I want the stuff in the square root to be greater than or equal to 0, but I don't want it to be 0 because it's in the denominator, so I clear that out. And so I end up with just x has to be greater than 7. So a lot easier to write on this one. This one is just going to be 7 to infinity with a parenthesis on the 7. For number 9, we've got a square root in the numerator, and we've got division. So we've got to worry about both of them here. So if I look at the numerator, since it's in the numerator, it can equal 0. So I want the stuff inside the square root to be greater than or equal to 0. If you solve through this, there's a couple ways you can do it. It'd be easiest, I think, if I just add the 2x over, then divide by 2. So you've got to read this backwards. X is less than or equal to 5/2. So that would mean, if I think about this as like on a number line, 5/2 and everything smaller than it. But I do have that little hitch that there is a number that would cause division by 0. That number is -4. So x can't be -4. So that means in my, if you think about it on the number line, I've got to add a small little open circle here in the old-fashioned way of doing it, an open circle at -4. So how do I write this in interval notation? This is everything from negative infinity to -4. Hop over -4. -4 to 5/2, and we were including 5/2. For the last one on this section, we've got ourselves a word problem here that deals with the piecewise defined function, which again is a different function for different parts of the domain. So the speed limit is 65 miles per hour, minimum is 40. So we've got a $15 fine for every mile above the max or below the min. So let's figure out what we would do here. Well, so x is my speed. If I am driving between 0 and 40 miles an hour, I'm going to get fined because the minimum is 40. Now the question is, how do I figure out how much I'm going to get fined? Well, what some students might say, which is a good starting place is, oh, it's $15 per mile. So 15 are miles per hour. So 15 times X. That doesn't quite work because it's how many miles under 40 am I going? So for example, if I was going 38 miles per hour, that's 2 miles below the minimum. So it would be a 15 times 2 fine. If I was going 30 miles an hour, that's 10 below, so it'd be 15 times 10. So in general, what I'm doing every time is I'm doing $15, and then I have to figure out how much below 40 I'm going. The way I do that is 40 minus X. So if I had a speed of 30 miles an hour, 30 would go in there, and then I'd have my 15 times 10. So if I distribute that, that's going to give me 600 minus 15x. That's how I would calculate the fine. If I am going between 40 and 65, there's no fine. So that's just 0, which is perfectly allowed. If I'm going over 65, again, I don't want to do 15 times X. I need to know how much I went over 65. So that would mean my speed minus 65. That would tell me how much I went over 65. And I'd multiply that by 15. And then if I distribute that, I've got 15x minus 975. So that does it for section 2.1.